This lesson is on the power rule and chain rule for derivatives. And before we get started, you need to remember a couple things about exponent rules. One is that when I have a fraction like 1 over x to the fifth, that can be written as x to the negative fifth, that negative power meaning that it was on the bottom of a fraction. And if you have a root, so here I have a cube root of x to the seventh, the power would go on the top and the root would go on the bottom of the exponent, and so I can rewrite this as x to the 7/3 power. And then I can have a combination of a fraction and a root, and so in this case I have a fifth root of x, or excuse me, a square root of x to the fifth power, but it's on the bottom of a fraction. So the fact that it's on the bottom of a fraction makes the power negative. The x had a power of 5, that's on top, and then a square root is an understood 2, and that goes on the bottom of the fractional exponent. Now, the reason I bring this up is because when you're getting ready to take a derivative and use the power rule, the chain rule, whatever, you really want to be in an exponent. So if I'm trying to take a derivative, be in this form. If I'm trying to solve an equation, it's easier actually to be in the fraction or the radical. But since we're working in derivatives, I'm going to be working in exponent form. Alright, the first rule that we're going to talk about today is the power rule, and we did kind of discover this in a previous lesson. And so what happens is, if you're given a function, here I have y equals a times x to the n. It's going to be any function. A represents a number and n represents a number. The derivative of that, you take the power n, multiply it by the coefficient in front, so that would be a times n, and that'll end up being a number. And then you subtract 1 from the exponent. And so that's what happens in these situations. So let's do some practice with those. My first example, I have y equals x cubed. So there's an understood 1 in front of the x. So my derivative, I would bring that 3 times 1 is 3. I still have the x, and then I subtract 1 from the power. So my derivative would be 3x squared. Number 2 is similar, except instead of an understood 1, we have a 2. So I take the 4, multiply it by the 2, put down my x, and subtract 1 from the power. In example 3, I have some pieces like that are put together with a subtraction. You could actually string out a very long polynomial if you wanted to, and just do it one piece at a time. So here I would treat the problem, the 7x squared, separately. So I would do 2 times 7 is 14x, and then the power of 1, which we don't normally write the power of 1. Then I would bring down my subtract, and I would do the derivative of 2x. Well, 2x is to the imaginary 1 power, and if I do 1 times 2, I get 2. And then I would be to the 0 power. Well, anything to the 0 power is 1. And so that would just leave me with this 2 here, because the x would be gone away. You can think of this piece, this 2x, like the lines, and when we graphed the lines, the slope of that line and the slope of the tangent line were the same because they were on top of each other. And so that's the linear piece here. The slope of a line, 2x, would be 2, and so that derivative would just be that slope, 2. 4 is your special case, and you can treat this, it's really best to think about this one when you're taking the derivative as being your horizontal line, because f of x equals 3 means you have a horizontal line at 3, and the slope of any horizontal line is 0 everywhere. Every single value has a slope of 0 there, and it's just easier to remember that the derivative of a plane number is 0 because that plane number represents a horizontal line, and the slope of that is 0. These two examples are examples where you have to turn things into exponential form and work with them. So I'm going to start by turning this into an exponent. And really, I can still leave that 1/3 as a 1/3, But the x on the bottom, I need to change it to an x to the negative 2. So I'm going to look at this as 1/3 x to the negative 2, and then I'm going to take my derivative. So do this algebra manipulation first, and then take my derivative. So negative 2 times 1/3 will be negative 2/3. And then I subtract 1 from the power. And you have to remember when you're working in negatives, if I have negative 2 and I subtract 1, I'm actually at negative 3. So don't get in the habit of thinking only in positive numbers. Number 6 is also one I need to rewrite my original function. I have y equals x, and it's a 5th root and a 2nd power. So I need to write that as x to the 2/5 power, and then take my derivative, my power rule. So I'm going to multiply the 2/5 times the understood 1, so 2/5 x, and then when I subtract 1 from the power, I think in fractions, so I think of 1 as 5/5. So 2/5 minus 5/5 would be a negative 3/5. It's just easier if you can think of 1 as being whatever the denominator is over itself. You can do that math a little bit better in your head. Okay, the second rule that we're going to talk about is the chain rule. And the chain rule comes about when you have a composition of functions. And remember, composition of functions is like f of g of x, where you have one inside the other. For example, if I had something like this, this would be a sine x inside of an x squared. So again, that's when we're going to recognize that we're going to use that chain rule. What works is you take the derivative of the outside first and you keep the inside the same, and then you multiply by the derivative of the inside. You can only work one layer at a time, work outside to in, and change one thing at a time. You'll see what I mean when I get to the examples. Okay, so example 7 is a basic example, and I have this x squared plus 2 inside of x to the 5th. What happens, again, you do the outside and then the inside. So if you can cover up the x squared plus 2 with your thumb and just think of this as x to the 5th, how would you do the derivative? Of course, it's a power rule. So you would do 5 times whatever that is to the 4th power. That's what I mean by taking the derivative of the outside. When you do that, the inside does not change. You cannot do it at the same time. So I've just done the power rule on the outside, the inside is staying the same. Then I want to multiply by the derivative of the inside. I just usually put it in parentheses in case there's a lot to it. And I don't think about the 5 now, I think about the x squared plus 2. What is the derivative of that? So that would be 2x plus 0, and I'm not going to write plus 0. That is how you do the derivative of something that is a composition. So let's roll down to number 8. So number 8, I also have a function inside of another function, and I have it in a square root. So before I start, I need to change that square root to a 1/2 power. So I'm going to look at this as 3x squared minus x plus 1 to the 1/2 power. Then when I go to take my derivative, again, put your thumb or whatever over what's in parentheses and just think about the outside. So I would have 1/2, big parentheses, and then 1/2 minus 1 would be a negative 1/2. That's my derivative of the outside. When I do that, I just copy the inside. 3x squared minus x plus 1. Cannot mess with it at that point. Then times it by the derivative of the inside. So only thinking about the inside now, my derivative would be 6x minus 1. Because the derivative of 1 is 0, I'm not going to put plus 0. But it's important to have this part in parentheses because it is attached with that minus, and we are multiplying by the entire derivative of the inside. Okay, and finally I have example 9, and again this one's in a fraction, so I need to change that form before I start, and I'm going to write that as x cubed minus 2x squared plus 3 to the negative 2, so that everything is in a power form, an exponent form. And when I go to take my derivative, again, don't think about the inside of the parentheses just yet, do the outside. So I would have negative 2, whatever to the negative 3, because when I subtract 1 from negative 2 again, I get negative 3. That's my outside derivative. Write down the inside, do not change it. Then multiply by whatever the derivative of the inside is. So that would be 3x squared minus 4x plus 0, but again I don't put plus 0, and I have that piece all in a parentheses because it is attached with a minus in there. And so this is the basic idea of the power rule and the chain rule. We will be adding more rules, and we will still be using the power rule and the chain rule with those. So we want to get these down to where we feel really comfortable with them and are really recognizing when to use them. So that concludes this lesson.